Algebra 1, Day 68. So today we're going to be talking about solving quadratic equations utilizing factoring. The great news about that is we've already done this. We know this topic inside and out. All we're doing today is talking about it in just a little bit more detail, okay? So your focus today shouldn't be anything beyond practicing factoring, okay? So let's go ahead and get jumped into it. Let's take a look at that notes page. So when we solve quadratic functions, we are looking for x-intercepts. So just as a reminder, whenever we solve these by doing factoring, we get x equals number, x equals number. Those are my x-intercepts, my zeros, my roots, my solutions, whatever they're going to call them. Okay? My x-intercepts are also called zeros, roots, and solutions. One method to solve these functions is called factoring. First, you must make sure your equation is quadratic. Second, it must be set equal to 0. Third, you have to factor. The three factoring methods that we know of are greatest common factor, so pulling out what they all have in common. That fancy difference of difference of squares. And that ACB method. That's what I call it. Lastly, we set each factor equal to 0 and solve for x. All right, so let's go ahead and jump into an example here. And we are going to be utilizing our calculator in order to verify our results. Okay, so first thing, they want me to go ahead and graph this as well as calculate it. So I could just go ahead and pull these values from my table, so we're not going to spend time on that. Instead, let's focus on factoring. So first thing I need to do is multiply a times c, 1 times 5, which is 5. I need two numbers that will multiply together to give me 5, add together to give me 6. I'll start at 1, 5. And lucky shot, those are the numbers. So now I'm going to go ahead and I'm going to break apart my b value. Now I'm going to go ahead and I'm going to factor out from the first two terms. Now I'm going to do it with the second two. I need to verify that the inside is exactly the same. If it is, I can combine like terms. I am now completely factored. However, they want me to find the actual x-intercepts. So I've got to split this apart. I can go ahead and solve for x. And I end up with x equals negative 5 and x equals negative 1. Meaning my graph should touch at the 2 points, negative 5, negative 1. I don't know anything else about it. Okay? So, now that I have this information, I can also calculate my vertex. Vertex, right? We've already done this. The x-coordinate of my vertex is negative b over 2a. So, negative 6 over 2 times 1. And that becomes negative 3. Now I can take that and plug that in and figure out where in the world that lands me. So I would say f of negative 3 equals negative 3 squared plus 6 times negative 3 plus 5. And I find out that the y value associated with that is -4. So if I go up here, -3, -4, that will be my vertex. My graph should look something like this. This is not going to be exact, but that's okay. We know the gist of it. And you can verify and create extra points by looking at these guys. I just want to verify that I did my factoring correctly. So I'm going to head over to my calculator, start a new graph. I'm going to go ahead and put in my question that they gave me. So that's going to be x squared plus 6x plus 5. Now I'm going to go ahead and I'm going to verify that. And I'm going to say this is the answer that I got for number 1. And it was x plus 5 times x plus 1. And look at that. They're right on top of each other. So I did my factoring correctly. And I have my solutions correctly. But I could have also just have typed this in. So I'm going to go back up here. Let's go back to tab. Let's look at my history here. I'm going to take off my answer. So this is my original equation. I'm going to go ahead and do a graph trace. Graph trace. And I'm going to move it along. 0 located at -1. Over. Vertex located at -3, -4. Over. And another 0 located at -5. So look at that. Exactly what we predicted. All right, so let's go ahead and jump to another example. So here we have another one with factoring. All right, so I'm going to go ahead and I'm going to factor this. So first thing I need to do is I'm going to multiply A times C. I need two numbers that when multiplied together will give me -16, but when added together will give me -6. So I know it's a negative number, at least one of them. So -1, +16, no, -2, +8. Well, that's +6. Okay, so let me switch them to -8. Yes, those are my numbers. So now I'm going to split apart my B value. Now I'm going to factor out of just the first two terms. Now I'm going to factor out of just the last two terms. I'm going to verify the inside is the same. And then I'm going to combine like terms. Now I can split them apart. And solve for each x. And look at that, there's my zeros. But let us go ahead and verify this. It should touch at x equals 8, should touch at x equals -2. So let me go ahead and graph this. I'm going to show a different way. So I'm going to start a new graph. I'm going to say x to the power of 2 minus 6x minus 16. And let's go ahead and do a graph trace on here as well. Okay, so let's head down, 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 down. Oh, it's gave me too far. All right, let me go up, 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 up. All right, there's a 0 located at -2, which is one of them that we predicted. Let's go ahead and head over to that other x-intercept. And there it is. It's located at x equals 8, which is also what we predicted. So we factored this correctly. I could have also taken the two factors, multiplied them together as a graph, and verified that they were the same. Lots of different ways to do the same exact thing. All right. Let's take a look at another one. What are the roots of this? They're asking the same exact thing. So let's go ahead and do that. A times C equals 6 times -6, -36. So I need two numbers that will multiply together will give me negative 36, and when added together will give me positive 5. So I know, because they're added together and give me positive 5, the positive number's got to be bigger, and one of them's got to be negative, because this guy's negative. Negative times a positive makes a negative. So first thing I'll say is, I'll just go ahead and give it a try. No. No, but we're getting close. Yes, those are my numbers. Let's go ahead and split apart that B value now. All right, now I'm going to factor out of just the first two terms. Then I'm going to factor out of the second two. I'm going to verify the inside is the same, and it is. And I'll go ahead and combine like terms. And I already know if I flip this number sign divided by this number, I'll get my answers. And I got them. 3 over 2, 2 over 3. Let's verify this by graphing it. So I'll go ahead and open up a new graph page. I'll type in my original equation. I'm going to go ahead and run my graph trace. So let's look for this. Negative. Oh, whoops, I made a mistake. Look at that. All right. So actually, this was supposed to be a plus. I just wrote it incorrectly. I was looking at the wrong part. So this should have been a negative. All right. Negative 1.5, which is negative 3 over 2. And 0.667, which is approximately 2 over 3. The other answer we got. All right. So again, all you're doing is factoring. You're finding these zeros, okay? So don't make it harder than it needs to be. You got this. You're super smart. I'll see you guys next time. Have a good rest of your day.